Okay, the parent function. Raise your hand. Who remembers the parent function can tell us? Raise your hand if you remember. Oh, we got one. Yes, thank you. Is that the same as f of x equals x squared? Yes. When we put f of x, that means it's a function. Remember in junior high you learned about the vertical line test of functions? So as long as the vertical line test passes, which means each x only has one y, and if you're in a functional relationship while dating, you're only going out with one girl at a time or one boy at a time, right? You're not being a player and dating multiple people. Otherwise, you're going to have a hard time being in a functional relationship and keeping straight which girl is the blonde and which girl is the redhead. I don't know, just kidding. Okay, but function, same way. Each x can only have one y value. So, f of x, if you see that, that tells you it is a function. It means the same though. Those are interchangeable, other than the f tells you it's a function. If it just says y, it's probably a function, but it might not be. Okay, so today we're going to practice that shortcut. Maybe I told you of it, maybe I didn't. I can't remember. Some classes I did, others I didn't. There is a shortcut to filling out your x, y tables faster. For quadratics. It only works with quadratics though. On a parent function, do you remember where that vertex was? Yeah, the origin of 0, 0. Okay? Yes, please. Now, when you label your graph and do the little tick marks, start at the origin and work your way out so they're even. And always label x's and y's, and I put numbers by the tick marks, at least one of them, so the reader can understand how you are counting. Starting at the origin, and we go down 1, 2, 3, 4, 5 again, negative 1, 2, 3, 4, 5, positive. Start at the origin, working out. Okay, we know it's symmetric, so it's really a nice function because it has 2 points at every height, right? So the shortcut was the next set of points follows the ratio 1 over 1. It kind of behaves like slope, but it's not a constant slope because it's curving, the slope is changing. Right? If you watch my hands, does the slope of my hands change as I curve them? Yeah, so the slope is constantly changing. But there is a nice pattern that happens. Yeah, do you remember rise over run for slope? So from your vertex, the next set of points, you can do an XY chart. That's totally fine. On quadratics, we could rise 1, run 1. Rise 1, run left 1. The next set of points follows the pattern. Have I already showed you this pattern? Good, 4 over 2. Rise 4, but you always go back to that vertex. Rise 4, run 2. Rise 4, run 2. And then when you draw your line through it, first of all, make sure those points are large enough that they're not going to disappear. Also, I said it's a line, that's a lie. It's a U. We call that a parabola. Make sure it's curved at the bottom. Make sure you bring it all the way up to the top with arrows. Okay? So, that's the parent function, and then we have some things that happen when we start attaching numbers. So I'm going to write this so many times for the next 3 years, it should be ingrained in your head. AH's and K's apply to all functions. Write that down, please. And we're going to review what the A does to the function, what the H does to the function, what the K does to the function. Y equals A times the quantity, X minus H squared, minus, or actually plus K. Okay, the multiplier guy out front. That guy out front does up to, well, 2 of 3 things. Could do up to 2 of them. Remember what the A does? Okay, it tells you the maximum minimum because it tells you if it's concave up or if it's concave down, right? If it flips down, oh, I just said the word. If it goes down, then it flips. And when does it flip? When A is negative. So we're going to write A is less than 0, meaning it's negative. It's going to flip, or flips. The graph will flip. Okay, put you on the spot. Gabe, what if A, the absolute value of A, is an integer greater than 1? So if absolute value of A is greater than 1, if we're multiplying by something greater than 1, think slope-wise, like 4 is greater than 1, right? So rise 4, run 1, rise 4, run 1, rise 4, run 1. Is that a vertical stretch or a vertical compression? Good, because if you see my fingers, I'm going up 4, over a little bit 1. But up is way more than going sideways, right? Up 4, rise 1. So if we have an integer greater than 1, it actually doesn't have to be an integer. 1.5 would be a stretch as well. As long as it's greater than an integer, greater than 1, we have a vertical stretch. And if you're stretching something, what happens with the sides, the slope-wise? Do they get steeper or less steep? Steeper, because you're stretching it, so it's pulling them in, and they're going to get steeper. It has a lot going on. One more. If A is a fraction, I'm going to say 0 is less than the absolute value of 1. A is a fraction like the fraction 1/2, because it behaves like slope, kind of. You go up 1, rise 2, up 1, rise 2, up 1, rise 2. You're actually getting wider. So what happens? It's a vertical compression, because when you compress something, it oozes out the sides. Vertical compression. And that means it's going to get less steep or wider. Okay, that has a lot. A tells you a ton of stuff. Now inside the function, and when I mean inside the function, I mean right by the x, inside the parentheses. Inside the function we have this guy, negative h. Who remembers, raise a hand, who remembers what that does to the graph? Tatiana? Horizontal shift, and in our head we say a word. Horizontal shift, you remember that word? Opposite. Who said that? Was that you, Brandon? Yeah. Good job. Horizontal shift, opposite, because it's a little confusing. If it says inside the function -2, even though the negative numbers are on the left, they're actually going to go right 2. If it says inside the function +3, even though the positives are on the right, we're going to go left 3. So in our head we just say opposite. And this shift for the K would be what shift? Vertical shift, and we say instead of opposite, we say the same. So if you watch my hand, opposite, same. This is actually your vertex. Opposite, same. Opposite, same. That's your vertex. So this guy, actually let's put in vertex. Opposite, the horizontal shift. Same for the vertical shift. That is your vertex. Actually, we need to add one more thing to our graph before we do a couple examples. Domain and range. Of our parent function, domain is the spread along the x-axis. That's why I put this little x. So we're looking horizontally. How far to the left does this graph go? And I'm actually doing the x-axis because all of these have an x coordinate as it continues up. So how far to the left does the graph go? Negative infinity. And we will never make it to negative infinity. We will die before we get there. So we put a parenthesis. Okay? How far to the right does the graph go? Naman? How far to the right does the graph go? Good. And are we going to ever make it there, Naman? Oh, so we have a parenthesis. So, a nice thing about quadratics is the domain is always the same. The range changes, though. And guys, these have to be written smallest to largest. Negative infinity is smaller, positive infinity is larger. So the range, we start at smallest to largest as well. Fingers in the air. What's the y value? Because range is looking at the y-axis. What's the y value of the lowest point? I said fingers in the air. Fingers in the air, not shouting out. There we go, better. What's the y value? Thanks for holding it up. 2 rows in the back there, I'm not seeing many hands up. What's the y value of that lowest point? There we go. 0, right? Is there actually a point at 0? Yes, so we put a good bracket. And then how high do we go? Infinity and beyond. Are we ever going to make it like Buzz Lightyear does? No. We wish, but it's not going to happen. Okay, now at the time I'm going to give you a couple examples, and without even graphing it, you should tell me exactly, because you have the key, exactly what's going to happen. Example 1. Y equals 4 times the quantity x minus 2 squared plus 3. Underneath it, I'm going to write A, H, and K. And then I'm going to say vertex. Those are things you should be able to identify just by looking at the equation. So my key is scrolled up, so you should have your key on your paper right in front of you. Okay, Felipe. What number is in the A position? 4. Good, so let's write a 4. Now let's decide what that 4 does to the graph. Katie. Caitlin. You go like Katie? Okay. Katie, what does the 4 do to the graph? Is 4 between 0 and 1, or is it greater than 1? Greater than 1, so on your key, look. What is it? Good, vertical stretch. And we can actually add to that. It's a factor of 4, because we're going to be times them by 4. Vertical stretch, let's add in by a factor of 4. Which is meaning it's getting steeper. 4 times steeper. Steeper quicker. Okay? Fingers in the air, please. What is the H value? And think in your head, what is the H value? Yeah, how do we do negative with our fingers? Like this. Good. Okay, turn to your neighbor, please, and describe to your partner what the negative 2 is going to do to the graph. Actually. Okay, who wants to volunteer their partner? Okay, who are you volunteering? Brandon is. You gotta get your hands up quick. Okay. Now I'm going to give Brandon a challenge because I'm going to limit him to 4 words. In 4 words, Brandon, can you tell me what this negative 2 does to the graph? Shift. Which direction? Horizontal doesn't flip though. Horizontal moves. So which way? You think opposite, so it would be, for the negative numbers are left. So we think opposite. So which direction is that? Right? How many? Oh, yeah, I was thinking 4. You're right. Okay. Horizontal shift. You guinea pig on the 4 words things. We can say it in 4 words. Horizontal shift. If it's negative, the negative numbers are on the left, so we think opposite, so it goes right. 4. 2. Sorry, I don't know why I keep thinking 4. That's the A value. Okay, show me fingers in the air, please. What is the K? Without shouting out. Fingers in the air, what is the K? What is the K? Good. I still have some holes for people not answering. What is the value of K? Okay, oops. Uriel, I saw we had 3 there. In 4 words, Uriel, can you tell me what the 3 does to the graph? Okay, we'll do those first. Everyone turn to your neighbor and discuss, and then come back to you. You have to tell me. Everyone turn to your neighbor and discuss. Come up with 4 words of what that K equaling 3 does. Okay, finish your conversations in 5, 4, bring it back here, 3, turn around, 2, be quiet, 1. Ariel, what does the 3 do in 4 words? Wait. Another round of applause. Yeah. Happy round of applause too. Awesome, yes, because it's same, right? We say same with that one. So if it's positive, it goes up. Vertical, shift, up, 3. Perfect. And we've just discovered our vertex. Everyone watch my hand, please. Watch my hand, please. Eyes this way. Opposite, same. So this guy is opposite, which would be what number? 2. Positive 2. Because opposite would be positive. Same, what's this number if we keep it the same? That is your vertex. Okay, we're going to graph this thing now. And guys, A is positive, so is it concave up or concave down? So if our vertex is already positive, I don't need any of the negative y's. I can save space on my paper by just doing an upside down T. If you would please put arrows, label X, put arrows, label Y. Start at the origin, come out here, 1, 2, 3 is probably fine, label a negative 3. 1, 2, 3, label positive 3. Actually, now that I look at it, I probably need a couple more. Or 5, because the vertex isn't at 0, 0 this time. And then I'm going to give myself at least 10, make sure I'm okay here. 1, 2, 3, 4. I like making my 5s a little longer, so that my eye can jump straight to that one instead of having to recount from 0 every time. We're going to do this by using the pattern of ratios off of the vertex. So if you can plot the vertex, right 2, up 3. Right 2, up 3. That's the vertex. 2, 3. Okay, now normally, guys, we'd say the next set does 1 over 1. But that's before we have a multiplier. If I multiply by 4, then I'm going to rise 4, run 1, because our A is 4. So I'm at 3. I'm going to rise 1, 2, 3, 4, and run 1, both directions. So I went up 4, and I went to the side 1. I was just showing you how I was moving. What? But we have a multiplier this time, A. So when there's a multiplier, we have to adjust because that means it's going to grow faster. It's going to be growing 4 times as fast. Okay, so that's why our normal thing is 1 over 1. We times, it's the rise that's rising faster. We times by 4, and so we're going to go up 4, run 1. Okay, now what was the next ratio? 4 over 2 But we have a multiplier of 4, so we really only need times the rising, which is the numerator. So we're going to be rising up to 16 over 2 from the vertex. That's not that bad. If I'm at 3, I'm going to go all the way to 3 plus 16 is 19. So you just do some more checks. 1, 2, 3, 4, 5, 6, 7, 8, 9. Rise up and go over. Rise up and go over 2. And then you're ready to put your parabola, make sure it's curved. We'll practice another one. Let's talk about domain and range before we do another problem. Domain. Turn to your neighbor, please, and tell them what the domain is. And be specific on brackets and parentheses, please. Turn to your neighbor and tell them the domain. Now turn to and tell them the range, please. You good with this? You got it cut out? Okay. Come back to me, please, in 3, 2, 1. Who wants to volunteer their neighbor? Oh, I saw right there. Who's volunteering, Kevin? Okay. That is all yours. Domain. Yep. Ah, you got the easy one, right? Parentheses. Thank you. Okay. Oh, he already has his hand out. He knows. Dominique, what's the range? Okay, now when I'm going to round, I'm going to hit some bracket zeros. Because what's range is the height, the y value. What's the y value of this guy? 3. So bracket 3 going up, 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 and away to infinity. Okay? Okay, let's try our second example. We have a quiz next time on this. Hint, hint, hint. We have a quiz next time on this.
Okay.
Okay, example 2. On the quiz, you're going to be doing exactly this, but without the calculator. You have to identify the A, the H, and the K, and you have to tell me the vertex just by looking at the equation. And then you have to graph it by hand. And the domain and range. Yep, so your packet from last time, this is reviewing that packet too. Okay, so A, H, and K. Let me put negative H because we do the opposite. Would you turn to your neighbor and go through all 3 of them and then agree upon them and write them down on your paper, what the number is and what it does. All 3 of them, please. Work with your neighbor. Work, work, work. I should hear you talking. Yeah, technically, to be mathematically correct, I should write as negative because we're doing the opposite of the number. H's and K's. H and K, you should be able to describe what they do in 4 words. Describe them too. Just them first. Good conversations. Okay. Okay, you need to write down our newest problem. I see you discussing, but I don't see that you've written it down yet. Okay. Quiet, please. First person to touch the top of their head who wants to volunteer. Oh, Brandon, you're fast, man. Maybe since he's in the front row and I see him first.
Very cool take.
Okay. Shh. Everyone quiet, please. Quiet. Thank you. Derek, tell me what the A is and be specific on what it does, please. Okay, and what does that do to the graph? That just flips it down. So it doesn't make it positive because flipping would make it extend down. But so actually going into the negatives, flips, and because it's a fraction between 0 and 1, or the absolute value is between 0 and 1, what does the fraction part do? Still you, Derek. You either have vertical stretch or vertical compression. Let's play. Put the food away, please. I'm starving too. My tummy's grumbling right now. We can eat in 12 minutes. Compression, because it's going to ooze out the sides. It goes up 1, out 2. By a factor of 1/2. Vertical compression by a factor of 1/2. So does it get steeper or less steep? If you go up 1, out 2,
Wider.
it's getting wider, so that's flattening it, it's getting less steep. Okay? And we get wider, less steep. A is a handful of stuff that you have to save. Okay, who has the next birthday? Who has a birthday soon? When's your birthday? October 24th. Anyone beat that? Okay. Quiet, please. Talk to the class. Caitlin, your choice. Who in the room is going to answer in 4 words what H does? Caitlin, your choice. Okay, right next door. Cassandra. Cassie. 4 words, please. What does the 4 do to the graph in 4 words? Wait. You agree with that? Oh, wait!
No.
Horizontal shift. It says positive and we think negative. So it goes left. 4. So on our... Okay, on the function, I would recommend putting HS, VS, opposite, same. Horizontal shift, because it's positive, we go opposite, which will actually be left, 4. Okay, who had a birthday in September? Okay, who are you going to volunteer in the room to tell us in 4 words what K does? Elena. In 4 words, what does K do? Do you agree? So -5, is it supposed to be the same? Yeah, so -5, vertical, shift, down, 5. Good, good, good. Okay. Vertex time. I need everyone's eyeballs up here. Watch my hand. Opposite, same. Opposite, same. So, the vertex will be shouted out. -4. There you go. Opposite would make it -4. Same would keep it -5. And we already know this is extending down, because Derek told us it flips. So when we draw our graph, you don't have to do all 4 quadrants. Whoops, that's awful. You only need to do a T for the negatives. Okay, let's graph. Graph. Draw your T. Put arrows, please. Label X and Y. I can see that we're starting on the X's way out at -4. So I'm going to give the left side enough. 1, 2, 3, 4, 5, 6, 7, 8. Just to make sure we have enough out there. And I can see the vertex is at -5, and I know it's going to be continuing downwards because it's negative, so I'm going to give a lot of negative Y tick marks. -5, -10, that's probably good. Because the multiplier of 1/2, so we won't be going down too much. That multiplier effects are rising, so when you're ready, plot the vertex, -4, 5. -5, -4, -5. Okay? Then, wait, let me make sure you're doing the pattern right. Normally it's like this. 1/1 for the next set of points, but the rise, that gets the multiplier. So 1/2 times 1, and actually, sorry, it's -1/2, mean -0.5, or -1/2, right? So from your vertex, you're going to go down a little bit and run 1, and I'm at -4. So right there and right here. Because it's supposed to be a wider, faster than it's going down. And then the next one was 4/2 times this guy by 1/2, so our rise is no longer 4, -1/2, sorry. The rise is -2, and we'll run +2. So always go back to that vertex. Back at the vertex, which is at -4, comma, -5. We're going to go down 2, and then run 2. Down 2, and run 2. And because it's a fraction, it's not going down very fast. It's going wider more than it was going down. And then just make sure you curve it out like a parabola. So, next time, domain and range, we need to do that before I say next time.
Oh, we don't need
Domain is always on parabolas. Good. Turn to your neighbor, please, and be specific on brackets and parentheses. Tell your neighbor, please, the range. It has to go smallest to largest. Okay, bring your conversations back, please. 4, 3, 2, 1. Okay, well, what'd you get for the range? What do you think? Thumbs up? Thumbs down? Is it true that -3 is smaller than -5? Yes, good job, and we do have a point, so it's a bracket. Make sure you always write those smallest to largest. So next time you have a quiz on pretty much exactly this. We'll be identifying A, H, and K, stating domain and range, and graphing by hand. You can use, guys, you can do an XY table if you like that way better. If you understand what we're doing with the patterns, you can use the patterns. Next time this packet is due, you should, what we talked about today should be solidifying this. You should be good to go on the packet. Okay? If you have a calculator, which most of you do, please come return it.